perform an activity for evaporation. Take a small amount of spirit in a cup. Pour a few drops on your palm. Your palm feels coldness. Let us see why this happens. Once again, take a few drops of spirit, say 1 ml, and pour the drops into 2 petri dishes individually. Generally, the petri dishes are shallow glass or plastic cylindrical lidded dishes used in the laboratory. Place both of the dishes under a ceiling fan. Close one of the dish with the lid. After 5 minutes, check the quantity of spirit in both dishes. We observe that spirit disappears in the dish, which is kept open under the ceiling fan. At the same time, some quantity of spirit can be found in the dish which is closed. Similar observations can be noted for the water drying up on the floor and in wet cloths under a ceiling fan. In all the above cases, the state of the liquid changes to vapor. This change in state of any liquid to vapor is called evaporation. Let us learn more about the process of evaporation to understand the reasons behind the above observations. The molecules of spirit continuously move with random speed in various directions when the spirit is kept in the closed dish. During their motion, these molecules collide with one another and transfer their energies. The molecules on the surface get enough energy to escape from the surface when they are collided with the molecules within the liquid. These molecules, after escaping from the liquid surface, collide with the air particles near the surface of the liquid. A few of them even return back to the liquid. Hence, when a liquid is exposed to air, the particles at the surface continuously escape from the surface until the entire liquid disappears. This process is called evaporation. Now, let us observe the reason for faster evaporation of spirit under the fan. In open air, the number of returning molecules is reduced to a large extent when air is blown over the surface of liquid. This is because any molecule escaping from the surface is taken away from the liquid surface, so this raises the rate of evaporation. That is why in an open pan, the spirit evaporates quickly than when it is closed. In this way, we learn that the process of evaporation is a surface phenomenon. Temperature falls during evaporation, thus making it a cooling process. As the molecules of liquid escape from the surface into the air, the process of evaporation also involves phase change. The rate of evaporation of liquid is determined by the factor like temperature, surface area of the liquid, and amount of vapor present in the surrounding air. Example: when we work, the body produces heat. This increases the temperature of the skin. As a result, water present in the sweat glands begins to evaporate. Depending on the factors of evaporation, the body becomes cool. The reverse of evaporation is technically known as condensation. Let us learn about this process in detail. Take a glass tumbler. Place it on the table. Fill half of it with cold water. We know that the temperature of the cold water is lower than the temperature of the surrounding air. Air has water molecules in the form of vapor. Molecules of water in air with higher energy collide with the water molecules in the glass tumbler with lower energy. As a result, water molecules in air lose their kinetic energy. This causes a drop in the temperature, and molecules of water in air are converted into droplets continuously. Hence, the water molecule's temperature in the glass tumbler increases. This process is called condensation and is a warming process. Condensation can also be defined as the change from gas to liquid state occurring at the surface of the liquid. For example, when we complete our bath in a bathroom with hot water, the number of vapor molecules per unit volume is high when compared with the outside. When you dry yourself with a towel, the vapor molecules surrounding us condense on our skin, thus making us feel warm. Let us learn the reasons for this.